She wouldn't agree much that it wasn't fair. You should have placed her.
Oh, my toenail fell off this morning. Well, my toenail came off this morning, but I stuck it back in my toe because I'm not ready to lose it. I just paid so much money to get my freaking nails done, both like my fingers and my toes. And so like I'm not wasting it. Just because literally that's like $5 a toe.
This was free, done by myself. That's why I'm probably just chipping everywhere. I'm probably gonna do my windows or the next prom I'm going to.
This is spelled incorrectly. Alright, here we go. Let's look at this worksheet first. Any questions or concerns on this worksheet?
Go ahead. On number 4, on is the middle top one C? Because that doesn't make sense to me.
Is this the one I told you one of them was jacked up?
Yes.
Which one was it?
It was C in the middle top one.
Alright, yeah, they don't match up. That one was jacked up.
I'm still a little fuzzy on like sketching the solution curve, like Swivl. I think it's like number 19 and 20.
Just viewing.
Alright, so what's the point they, well I can't read that. What's the point does it say? 0, 2? Alright, so 0, 2 is going to be right here. And then from there, all you're doing is kind of following the pattern of the slope fields that surround it. Okay? So kind of as they drew here, they drew one that goes through the point 0, 1. So that means 0, 2 is going to look similar. It's going to go that direction and that direction. Okay? What was the other point they gave me? 0, negative 1. So 0, negative 1. Okay? If I look at the slopes around it, which way is it going to go? It's going to go down. It's going to curve down. So that one's going to curve down this direction. Like that. That's all it's like.
Did you draw it through the lines they give you, or do you like go between them?
It doesn't have to be. It's you just. There's no perfect answer. Okay. If you get close, it's gonna be good enough.
Is that going to be
20, the same thing. What's the point? 0, 1. So 0, 1 is right there. So I'm gonna say it goes up there, and then we go that direction there. What's the other point? Negative 3, 0. So I'm going to say it goes that direction and then goes down. Okay, so you don't have to get exact. And this problem's not going to show up on the AP test.
Is it on the test?
I don't think so. All right, what else on this assignment? Other questions from this assignment before we move to the test review? Yes.
Can you explain the difference between sine and cosine? Is it just where the point starts?
It depends on if you're looking at y equals or dy over dx equals.
I believe it was y equals.
All right, so sine, if you remember, sine is going to start here and then go up and go that direction. That's sine. Cosine is going to start up here and then go down in both directions.
So E would be sine?
So if I look at this one, to me this looks like it's maxing out at this value, which means it would match up with this graph. So this one's going to be cosine. This one, because of the slants on the y-axis, that tells me we're crossing like sine is. So that's how you tell the difference.
And then what's different if it's the derivative?
If it's the derivative, then everything's going to be switched. Okay. Because what's the derivative of sine? Cosine. So if I got dy dx equals sine, then that means the graph I'm going to see is cosine. If I got dy dx equals cosine, then that means the graph I'm going to see is sine. Anything else on this? All right, Lee, which one did we definitely need to work on this? The one with the 2/3 or 3/2 or
It's
something?
number 9. It's number 7.
7?
Oh, and oh wait, no, never mind.
Yeah, 7 is the one I definitely want to do. All right, so 7. Okay. Abby can attest to this. 7 is definitely one of those where you need to follow my rule when it comes to coefficients. Okay, what's my rule when it comes to coefficients in your separator? They stay over there. Okay, so make sure they stay over there. So when I switch this, I'm going to get 1 over y dy. This is a coefficient, so it's 2/3. And then make sure this x, where is that x located? In the denominator. So make sure it stays 1 over x. Okay.
So why did you multiply? How come you need to divide? Because you're multiplied.
If it's in the numerator here, it's got to be in the denominator here. It has to be in the opposite location across from the equal sign. So then we integrate. I get the natural log of y. 2/3 stay. I get the natural log of x. And if you leave the coefficient over here and pull it out, it makes this problem so much easier. All right, my point is 8,2, so I plug it in. Which gives me that. If I've got a number in front of a natural log, where does that number go? Exponent. That number goes here. All right, so what is the 2/3 wanting to do to the 8? What's the bottom number? This is the root. The bottom number is the root. So I want the cube root of 8, which is 2, and then I want to square 2, which is... So I've got to subtract the natural log of 4 over here. So when I put those two natural logs together, I get 1/2. So C is the natural log of 1/2.
So whenever it just says solve the differential equation, you're only have to find C.
Solve it. I'm not done with it.
Okay, so with the solve,
It says solve, that means you got to get y by itself.
but it just says.
If it says find the value, there is one we'll get to. I think it's the next to last
All
problem.
right, find the specific solution.
Right.
That's just finding C.
That's finding y.
So what's the difference? Why do they say find the specific solution and then solve the differential equation when you both want the same thing?
Exactly. You got to know how to do both. You got to know both of those mean the same thing.
That's so stupid. You said the same thing.
And that's part of the AP world, is you got to know what things are asking for, and you can ask for things in more than one way. Same thing in real life. You can get stuff done by asking it in several different ways, but you're still going to get it done. Same thing here. All right, so let's plug that back in. All right, so now we got to get y by itself. Now, again, we want to move this. So we want to make that 2/3. And then to get rid of the natural log, E. So both of these have the natural log. So this is going to turn into 1/2 absolute value of x, 2/3. And what did most of us do on the test right here with this absolute value of x?
Got rid of it.
Most of us dropped the absolute value on the quiz. Don't do that. Okay? get rid of the absolute value, so I need the plus or the minus here. I look at the point they gave me. The point they gave me tells me I want to choose the positive. Now, on this one, I actually do not need the absolute value. Somebody raise your hand and tell me why I do not need the absolute value on this one. Somebody that wasn't with me this morning, yes?
Because you're squaring it.
Because I'm squaring it. That's why. Because if I square it, it's always going to turn positive, therefore I don't need it. It's not wrong if you have it, but in this case you don't need it because you're squaring it, it takes care of it.
So when do you get E in your answer? Like when you have multiply by natural log?
Well, if this didn't have the natural log in it, then I would have E in my answer.
So
But if everything has a natural log and there's no other variable outside of the natural log, then there's not going to be an E.
So say it was just the 1/2 is just plus 1/2.
Then it'd be E to the 1/2.
So then what was it before the natural log of x? But natural log after value of x, would that be with the E or be separate? What would the final answer look like if it was just plus 1/2? It didn't have natural log. Natural log wasn't there. That's why.
All right, what else on this? Tyler?
Let's see.
All right, what's the differential equation? All right. Everybody with me there? Now, a lot of people are getting hung up on when I have something like this. Okay, make sure we understand that that right there is the same thing. Same thing as this. For some reason, you guys can integrate this, but you have trouble integrating that. So if something's like this, always rewrite it like that.
Yeah, that was fun. You did?
My throat is really scratchy.
How was Chick-fil-A?
Yeah, what'd
Good.
you get from Chick-fil-A?
What?
What'd you get?
Number one.
What's fries? Did you get your fries large too?
I shared my fries though.
What kind of sauce?
They were
did you get?
community fries.
Wait, why?
What?
So you share it with?
Miss Dozier and Miss Nice.
So you shared a large fry with 3 people. Wow, so you got those many fries.
All right, here we go.
Hey, what kind of sauce do you get?
I don't. If I'm getting a sandwich, I don't get sauce.
You don't put nothing on it?
Huh?
It's not thick. You gotta put 2 slices. I don't like 2
All right. So when I integrate natural log absolute value of y, I've got the 1/2. If I integrate x, I get 1/2 x squared. So my point is it 1/1?
Yeah.
So natural log of 1 equals 1/4 times 1 plus c. So c is negative 1/4. Get rid of the natural log. And Zach, this time the E stays. Why does the E stay this time?
Because you don't have any natural log.
I have no natural logs over here, so the E's got to stay.
One natural log over there.
We got one natural log, then whatever's inside of it goes in front.
Why is it?
Because when I solve this and move it over, it's going to be bigger.
So then, if you had natural log on the 1/4, would it be natural? Would it be 1/4 e to the 1/4 x squared?
If I had a natural log on this,
Yes.
I'd have a 1/4 here,
And then
and that would be gone.
so it'd still be 1/4. So it'd be 1/4 e to the 1/4 x squared. Okay. But if it's all natural log, then your answer is natural log 9. Right.
If it's all natural log,
Yeah.
then the E might go away. We'll do one here in a second where the natural log has to stay there. I'll show you why.
Is that E negative?
No, I'm just putting a spot. So now I want to choose, is this going to be positive or negative?
Oh, it's positive.
Oh, there it is. All right, what else?
Number 3.
Number 9.
Number 8.
All right. So when I separate, should be easy on the right side. It's going to be negative x dx. What's the left side going to look like? Natural log y over y. And on the last unit we did, I told you anytime you see this inside of an integral, it has to be your u. Okay, what works out for us there? The y is canceled. So I'm just looking at the integral of u du. And if I integrate u, I get 1/2 u squared. I'm going to stick that back in there to save some board room. Okay, let me pause, make sure you're with me and understand how we got to where we are. All right, tell me.
1/2 integral of y squared.
Because if I integrate this right here, I get 1/2 u squared. And then I just put that back in there. Good? All right, plug in e squared and 0. Natural log of e squared. 2 squared, 4 times 1/2. 2.
Yeah, so wait, how do you just leave 2 there though? And that's log E
This is equal to that. All right, multiply by 2. And square root. At this point, let's go ahead and choose whether or not we want the plus or the minus. Which one do we want? We want the plus. So then the only thing left is my final answer.
So we would choose negative if the points were negative?
If it wanted, if this 2 up here was a negative 2, then this would have to be negative to get a negative 2. If you don't feel comfortable choosing it here, go ahead and put plus or minus, and then put plus or minus there, and then plug in your 0, and then you should see I need the top to be a 2. The only way it can be a 2 is if I choose the plus. So you can wait if you want.
So if e, she was e in the negative 2, 2. Would it still work for y is greater than 0? Because can you look there to tell?
Well, e of the -2 is still positive.
Okay.
Because e of the -2 is just 1 over e squared.
I should.
Okay. Why are they saying that y has to be greater than 0?
Because it's multiplied. Because it has negative.
There you go. I can't have a negative inside of a natural log. That's why y has to be greater than 0. All right. What else? 3?
Yeah.
Four needs to be done for sure.
All right. So if I separate, again, when do I not move the y up?
It doesn't have anything. Not big. It has a 1.
When I have an exponent of 1, it's got to stay down there. All right. So
Why is it -1 over 2y squared? So you put on. You don't have to put over where you get it.
It should be. All right. Plug in 2.5. So 1/2 right here. Squared is 1/4. It turns into a half. And what am I plugging in? 2 here. So that's 2. All right. This right here is the same thing as what? -2, move it over, we get C is -4. All right, now what? Multiply by -2. No, what do we do anytime I've got y by itself right here? Switch it. And then square root. Pick which one I want. Which one do I want? I want the positive.
Do you actually want to positive? Do you actually want to write the positive sign?
Say it again.
If it's positive, you want to actually write the positive sign.
You don't have to.
Do we need to show that stuff?
No. If you don't have the right sign here, how many points are you going to lose? 2. Remember, point number 1 is separation. Points number 2 and 3, integration plus C. Point 4,
Getting y by yourself.
plug in. Point 4 is plug in. The last point, getting y by itself. Okay, so if you do everything to get y by itself correctly, you're going to get 4 out of 5 or 5 out of 6. So we're not stressing out if we can't get y by itself.
Well, they take points off if you don't like multiply something out, like the y equals something, it's like something big and you just didn't like simplify it.
So you can leave it.
On 4, do you just get like y prime by itself, or what do you do?
Yes. You get y prime by itself
So
and then
just like
separate.
So add that over and then divide that over.
Yeah. Add that, divide by that.
Okay, and then you
separate.
just separate.
Yep.
Okay, so on number 9, I put like 3.71, and then I get some.
Let's just do it.
Yeah,
tell me where I'm at the left edge.
There.
Right here.
That's the farthest step.
Yep. All right, number 9. Certain type of bacteria present in a culture is growing at a rate directly proportional to the number of bacteria present. So I'm going to do dB over dt, and what's that going to equal to? KB, or whatever your variable is. All right. Suppose that on the 3rd day, 2,500 bacteria are present, while on the 5th day, 6,000 bacteria are present. How many bacteria were present to begin with? All right. Separate. Any questions on separating?
We get 160.
That's a B. Okay, now here's where this problem is different. Usually I get to plug something in, and what happens to this right here? It goes to 0. So that's where this problem is different. This problem gives me my first point I'm plugging in is 3 and 2,500. But I'm going to do what I continue to do. Okay, what do I usually do once I plug in? I solve for C. I'm going to go ahead and do that. The only thing is that my C has a K in it. No big deal. Okay, if you notice, C is equal to this, so I plug this in right there. That's why this is there. Everybody with me? Okay, now at this point, I'm going to do something that's not necessary, but I think it makes life a lot easier. I've got KT here, and I've got minus 3K there. What can I do with these two to simplify things? I can pull out a K. Again, it's not necessary. You can still get the answer correctly, but to me, it's easier.
How did you pull out a K? I thought you did 2,500.
Well, notice I only pulled out the K with what? I only pulled out the K with these two things. This stayed the same.
So you're telling me, like, when you have x squared minus x plus 3, you still pull out an x?
If with just those two, yes. If I had x squared minus x plus 3, I can do that. But notice I'm only doing it with the stuff that has the x in it. Same thing here. I'm only doing this with the stuff that has the k in it. All right, and then we can plug in the next set, 5 and 6,000. So if I plug 5 in there, I'm going to get 2, which gives me this. All right, when I put these two natural logs together, what am I going to get? The two zeros are going to cancel. I get 60 over 25. What goes into both of those? 5. And then I divide by the 2. So we get k equals 1/2 natural log of 12/5. Okay, and notice all I did, I stuck my k in. Okay, we just found k was this, so I plugged it in. Now, here's where you need to pay attention. Did it tell me that it wanted an equation for B? It did not tell me to solve for B. So since it did not tell me to solve for B, what can I go ahead and do here? I can plug in and get the answer. Okay, it's wanting to know how many bacteria were present to begin with. So that means, what am I going to plug in? 0 for T. So that's going to make it a -3 there. But I got it solved for B anyway, so it doesn't really matter. But sometimes it's a little bit easier. All right, so, and since this is a calculator, I'm not going to worry about doing too much work. I'm gonna let my calculator do all the work. Okay, and since I can't have a negative amount of bacteria, I know it's going to be E 1/2 natural log 12/5. And then whatever I get when I plug that in. You plug it in, John Ryan?
Yeah, 672. But there's a decimal. I mean, you can't really have like 3/10 of bacteria, so you just want to round down.
You do. So that means 672 bacteria represents what?
Day 0.
How much I started with. That's how many bacteria I started with.
So while out there, you get natural logs on each one. You use these.
Say it again.
You get natural logs on each part of that problem, but you use these too.
Because I'm going to use my calculator. I'm not going to simplify stuff by hand if I'm just going to punch it in my calculator. It's unnecessary and gives me another opportunity to mess up.
Could you just plug that in?
So you plug this in right here, just like it sits, it's going to give you this. And if you wanted to, you could do the 2500 to the front. You could do that, it's going to spit out the same answer. But this is just one more step, and it's one more step that I could screw up on, so I'm going to plug this into my calculator.
What I'm saying is, like, the last time we had like natural log on all the parts of the problem, you didn't use it. You just used a natural log. I don't know what problem it was.
You're saying all the natural logs canceled out?
No, like you had natural log over there, but then like you had natural log or something plus natural log or something, and you still simplify it down to there. That's the value, whatever your value, after value y, you had a natural log left.
Just because you did it by hand, like you didn't put it in the calculator.
I know there wasn't an e there.
I don't understand what you're saying. All right, what else? You got 10 minutes left. Water leaks out of a cylindrical barrel at a rate proportional to the square root of the height of the water in the barrel at that moment. So what we're looking at here? Say again. All right, very good. Questions on that? Make sure you pay attention to this word right here. Because what are some people going to write down instead of the square root? Square. And sometimes when the problem asks for a square, what are some people going to write down? Square root. When you hear square root, make sure you're paying attention and getting the right one. All right, when I separate, I get that.
This is part A.
Oh, sorry. I'm getting ahead of myself. Thank you. All right, we did part A. Part A, that's part A.
Okay, that's just it.
That's part A. So I'm working on part B now. So KT plus C there, what do I get here? 2H to the 1/2. I'm getting ahead.
Yeah.
All right.
Why is negative 1/2 H to the negative?
Because when I divided it over, it was on the bottom,
Oh,
and I need to move it up. All right, it says at 10 a.m. on July 1st, the depth of the water was measured to be 49 inches. That's my very first measurement, so that means my time is 0. So I stick 49 in here. Square root of 49 is times 2. 0 is going in there. So we see C is 14. All right, the next measurement says 4 hours later, the depth is 36. So stick 36 in here, square root of 36 times 2. My time is 4. So I subtract. And we get K is negative 1/2. And it says solve the differential equation, so what does that mean I have to do? I have to get H by itself. So I'm dividing. And then to get rid of that 1/2, square it. So there's part B. C says, what's the depth of the water at 10 p.m.? So what's my time at 10 p.m.? 12 hours. Okay, don't put in 10. Why is it 12 hours? I started at 10 a.m. So 10 p.m. is 12 hours later. All right. So this right here gives me negative 3. Negative 3 plus 7 is 4. 4 squared is 16. What's my units? Inches. All right. What's the last part of the question? Say it again.
Where'd you plug this in? Oh, I was thinking to put it in 10.
All right. What is the last question part? What time is it empty? So if it's empty, what does that mean? Height is 0. All right. So I get rid of the square. Gives me that. Subtract the 7. Multiply by negative 4. So if it's 28 hours later, and I started at 10 a.m. on July 1st, 28 hours later is July 2nd, and my time is 2 p.m.
From 10 a.m.?
28 hours from 10 a.m.
Why wouldn't it be before 10 a.m.?
What?
Why wouldn't it be before 10 a.m.?
Why wouldn't it be before this time on July 1st? What started out with water in it? So that means time has to pass to let the water drain out.
Okay, yeah, and it's, okay.
All right, so whatever I did not cover in class today, I'll cover that in a separate video. Which problems did we, how many did we not do?
We just did do 4. Oh, just kidding. I just didn't count. 1, 5, 3, 4, 5, 6, 7, 8. We just didn't do 8 of them. But 3 of them are bodies,
Salt fields.
the thing, and then 1 of them is like a part of